Next topic is mold materials. We have completed regarding pattern. Now mold make steps in mold and core making. Mold. What is a mold material? What are mold materials in mold making used? For mold making, mold materials used are majorly, especially sand molds. Silica sand, (70 to 75%), clay 15 to 20%, water 6 to 8%. Next remaining percentage 1 or 2% is additives. (3 to 5% additives). So what are these additives used, and what is the purpose of clay and water? These are more important. So the purpose of clay is used for bonding strength. Clay in a sand mold is used for bonding strength. Water, we are using water also. Water is used for increasing the bonding strength. For increasing bonding strength. So the amount of water we have to maintain properly, otherwise again strength will decrease. Here there one point you need to remember. One is green sand molds, another one is dry sand molds. So what is green sand mold? Green sand mold, if water is the water acts as strengthening agent or bonding agent, along with clay, then it is called green sand molds. 2011 gate bit 1 mark. Dry sand molds. So instead of water, we have to use sodium silicate. Instead of water, if we use sodium silicate, then it is called dry sand molds. So this is a major difference between dry sand molds and green sand molds. Next, additives. So what are the additives we use? So coal dust is one additive. What is the purpose? To increase heat resistance. So the mold has to withstand higher temperatures of the molten metal. So for that to increase the heat resistance of mold. Coal dust helps by adding coal dust, it increases the heat resistance of the mold to withstand the higher temperatures. Next one is wood powder and sawdust. So the powder which is coming from wood or sawdust means in sawing it will come wood powder only. So to improve collapsibility of the mold. What is the purpose of collapsibility? Collapsibility means easily breaking the mold. Starch and dextrin. To improve the resistance to deformation. So these are the mold materials which are necessary to add along with sand. So water and clay, these are essential, you need to add. There is another type of mold, this is sand molds. For metal molds you don't need to add anything. For metal molds very special purpose you use, very rare, those are different types of casting. If you use metal molds, those are called die castings. So that is discussed later, but first we will measure more importance is sand molds. Properties of sand material. So sand is a major component, silica sand. So for that we need to give more importance. What are the properties of sand material? I'm sorry. First one is porosity. Sand material has to be porous to allow the gases inside. So why it is necessary? We know that in sand mold cavity is an empty space. After removing the pattern, the empty space will form. So to get to obtain casting, we need to pour the molten metal into the cavity. So before pouring molten metal into the cavity, the air will be occupied in that. Once you pour molten metal, so the air which is present in the cavity has to go out. So how to go out means that because it is sand mold, there is a space between each sand particle, minute space. So that the air has to pass through these pores, come out of the sand mold. So this is that's why porosity is important. Porosity, ability of porosity, not porosity. Porosity is a property of a sand mold porosity ability of escaping the gases or air through the mold material. Ability of escaping the gases or air which is present in the cavity through the mold material. Especially here sand. So porosity is one of the important property. So how to determine the porosity? Okay, so porosity increases with decrease in clay. As we have discussed that clay acts as a bonding strength between each sand particle, so and this clay and go and occupy the space between the minute space between each sand particle. So if the clay percentage increases, porosity decreases. So porosity decreases with increase in percentage of clay so how porosity also increases, porosity decreases with the increase of percentage of clay, porosity decreases with increase in percentage of clay, porosity decreases with increase of ramming force. So how porosity decreases with increase in ramming force is why do we need to do ramming is ramming helps us to increase the bonding strength between the sand particle. So after pouring into the sand, we will apply external force such that it will hold properly. Even after removing pattern, it will the sand particles, the mold will get the shape of the pattern, and the sand particle won't fall into the cavity. So for that, porosity decreases as we increase ramming force goes on increasing, the sand particles come closer and closer. So porosity is determined by permeability. So permeability is a measure used to determine porosity. For this, permeability test is there. Permeability test is a standard with standard specimen we need to prepare. So here what is the standard thing is you need to keep the sand specimen in a sealing. So this is one of the cylindrical shape specimen. This is sand specimen. Sorry, this is sand specimen and cylindrical casing that has to be circular shape, and you have to keep that in an enclosure. This is outside is enclosure, maybe cylindrical or rectangular enclosure. So it has to be circular disc shape of specimen is the sand specimen. This one is enclosure, rectangular or cylindrical or whatever the structure. So the circular disc is sand one. This is sand specimen. Testing sand. Suppose for example you are doing preparing mold with a particular sand. First you take that particular sand and prepare the circular disc and keep that circular disc in this specimen, and allow here the gases will present, the gases below the allow the gases present in the bottom of the sand to outside, because of pressure difference it will go out. So the time we have to measure the time taken to move to come out of the gases. So that is what permeability number is a measure function of time. So what are the notations we need to remember? The volume will be filled with air pressure. Okay, first point you need to remember, the volume of enclosure is filled with air pressure. This pressurized is air. Okay, P. This P has to be greater than P atmospheric. Here it is P. Here it is P. Outside is P atmosphere. Next, note down the time taken to bring the volume V to the atmospheric pressure. This is V. Note down the time taken to bring the volume V to the atmospheric pressure. P. So that means P has to become equal to atmosphere. How much time we need to measure? T equal to time in minutes. Units are more important. D equal to diameter of the disc. It is standard in centimeter. See 5.08. So the diameter is 5.08 centimeter. H is height of the disc. again same height, 5.08 centimeter. V equal to volume of this material is equal to the volume below the volume of air, 200 centimeter cube. Air is pressurized air. P equal to pressure. So permeability number, this permeability number, how we need to calculate? Permeability number Pn equal to Vh by PAT. V is the volume, H is the height, P is the pressure, A is the area, and T is the time. Substitute all the values, whatever standard, these are standard values, only variable one is T, time taken to escape the gases. If you simplify it, the value you will get is standard value of permeability number you will get is 50.18 by T. Okay, this is important. The pressure you need to take 10 grams per centimeter square. Okay, external pressure, for external pressure. So this one is 501.8 by Pt. If P equal to 10 grams per centimeter square, for example, then Pn equal to 50.18 divided by T. So this one is standard formula. So porosity is a property of molding sand. Permeability is measure of quantity of porosity. So permeability number tells us how much is the porosity. If the time taken is more, so it is less porous, inversely proportional. This is one of the important metric, porosity. Next, strength. Strength is also one of the important property of sand mold. Strength, there are two types, grain strength and dry strength. First one is grain strength. As we have discussed that grain sand mold, which is called, if the water is used, it is called green sand mold. Instead of water, if you use sodium silicate, then it is called dry sand mold. So for green sand mold, green strength will come, addition of water to green sand mold, the strength increases. Addition of water to green sand mold. Is green strength. Gives green strength. B, dry strength. Without addition of water to the molding sand is called dry strength. What is the strength of the mold at dry condition without adding water? Here again you can measure the strength like tensile strength, compressive strength, shear strength. All these strengths are measured with universal testing machine. Universal testing machine is used to measure strength. Whether it is dry strength or it is green strength, whatever it is. Next property, the second one is strength, third one is refractiveness. Ability to withstand high temperatures of the molten metal. Ability of the sand mold to withstand high temperatures of molten metal without producing cracks is called refractiveness. So as we have discussed already that by adding additive coal dust, it increases heat resistance. So similarly here we are mentioning instead of property, refractiveness. Ability of sand mold to withstand higher temperatures of molten metal. So molten metal will be a higher temperature, so to withstand that higher temperature, ability of the sand mold to withstand higher temperature of molten metal without producing cracks in the sand mold. Without producing cracks in sand mold is called refractiveness. So why, if it produces cracks, what will happen? The molten metal will enter into the cracks, and again external projections will come on the casting, which is a waste of the material, and it will become as a defect. So again so many things will come into picture. So as we have discussed that refractiveness, it is increased by adding coal dust. Next, cohesiveness. As we know that cohesive property is attraction force between same molecules. Here cohesiveness is attractive force between the sand particles, because in mold is sand, considering as sand mold, so ability of adhering the particles increases strength of the mold. Ability of adhering sand particles with each other which increases shear strength or strength. Next property is adhesiveness. So cohesiveness is attractive force between same type of molecules. Here adhesive property is also a attractive property, but between different molecules. So ability of adhering the sand particles with other material like like flask. So what happens is, in preparing mold, we keep the entire mold in one enclosure, sand casing or sand flask, you can say whatever name. So this one. So suppose if I am creating rectangular casting, so once the cavity is removed, the pattern is removed, you will find empty space, and this is a sand particle. So that sand particle, if there is attractive force between the same sand particle, then that is cohesive force. Sand, and this one is wooden flask. So attractive force between the sand inside sand particle and wooden flask is adhesiveness, and attractive force between the sand particles in the sand mold is called cohesiveness. Next property is collapsibility. Ability of breaking the sand with a little amount of force. See, after sand preparation and after mold preparation and cavity preparation, we pour the molten metal into the mold, which enters into the cavity and forms casting. Once the casting is formed, we need to remove the casting. After removing the casting, after completion of manufacturing process, you need to break the mold, right? To break the mold, if the mold more cohesive strength is there, then and adhesive strength is there, it will be sticking to the mold box. So to avoid that, you need an external large huge amount of external force to break that one. So to avoid that, collapsibility property has to be there. So ability of breaking the sand mold with a little amount of force. Ability of breaking the sand with little amount of force. So it increases by adding wood powder to the molding sand. By adding wood powder or sawdust to molding sand. Next one is flowability. FLOWABILITY. Flowability is the property of sand, ability of the sand particle to flow into every corner of the mold. So the sand particle has to be, fill entire the space. So if there is any gaps in the sand mold or inside the if it's not filling properly, again it will create defects in the casting. So ability of sand particle to flow into every corner of the mold, so which is a property of molding sand. So these are the important properties of the molding sand which you need to remember. They ask questions like, for molten metal there is another property which is similar to flowability, that is called fluidity. Don't confuse between fluidity and flowability. Next, methods of making mold. So till now we have discussed the mold materials and properties of mold materials. So after that we need to discuss, now we are discussing methods of making mold. So after getting all mold materials, how to prepare the mold. So first one is hand molding. So hand molding is mold is prepared by using ramming force with hand. So ramming force is here external force. So in all our foundries, where mostly in BTech foundry first year, so you may have done sand molds. There you should apply only sand force with sand. That is called sand molding, the preparation of mold with hand. Second one is machine molding. So the external for complex for big molds, if you want to prepare big mold, and for that with hand you can't apply the force. You can't, you don't have that much enough force with you to apply, so it will take time also. For instead of that you need to use machine. So there are different methods. First one is this one is ramming is done by machine. First method is jolting. So in this jolting, force required for ramming action is obtained from external force of the machine. This machine molding is used for large size molds. Jolting, sand filled mold is raised up to certain height and dropped into the ground. then ramming action takes place. Okay, so by using guideways only we drop the sand filled mold. So by the here potential energy possessed by the mold after lifting certain height will be converting into ramming force as I hit the ground. So the from the ground there is an equal and opposite force from the ground. The weight then ramming will action takes place. The disadvantage is at the top of the molding sand will be like loose sand only, and so we get non-uniform ramming, but only at bottom we get good ramming. So that this is a problem here. So this is the mold box where you see cavity. This is a molding sand. So you need to drop this box, lift the box and drop it from certain height. Sand filled mold is raised certain height and dropped from there. Dropped onto ground. Then ramming action takes place. Here the potential energy possessed by the mold will be acting as ramming, helps ramming action. Potential energy possessed by the mold will be acting as ramming force. Once it drops onto the ground, because of potential energy and the opposite action takes place, opposite force will act on the bottom of the sand mold, which compresses the sand. So limitations. At the top of molding sand will be like loose sand. So ramming action will be non-uniform. Throughout sand mold. So more ramming at the bottom and no ramming or less ramming, negligible ramming force acts on top of molding box or molding mold, which results in loose sand on top. To avoid this, there is another technique called squeezing. So in squeezing, what happens is, by using a plate which dimensions are equal to the mold dimension, we put this plate on the molding sand and apply large amount of force by using hydraulic press. So here, suppose for example drawing is, so this is a mold, for example molding box, and this is molding sand, it's mold. We apply external force, some external apply external force. So plate which is to apply external force by using a plate which has or which have same dimensions as mold. External force is applied. So external force means here compressive force. So because of compress applied with the help of hydraulic press, not with hand. So hydraulic press, so much pressure will come, you can apply a huge force. You can use some other press also, doesn't matter. So here good ramming takes place on the top. Good ramming takes place on top of mold. So and poor ramming at the bottom of the mold. So it is exactly reverse to the jolting. In jolting we are allowing to fall the molding box from a certain height such that ramming action takes place due to potential energy. But here instead of that, we keep the molding box on ground, apply external force on the top of the compressive force, on the top of the continuous force, on the top of the molding sand. So ramming action takes place, ramming action takes place on the top in squeezing and on the bottom in jolting. To avoid this, there is another technique, jolt and squeezing. To overcome this limitation, jolt and squeezing is a combination of jolting and squeezing process. Combine jolting and squeezing process. Always you need to do jolting first. Jolting you need to do first, then squeezing to get uniform ramming. Almost all. Another technique is called sand slinging. This is used for only uniform section components. Here small quantity of molding sand thrown into the mold by machine. So it's like, you have to throw the molding sand into the mold. So because of that, the amount of force you are applying for throwing the sand, due to that force ramming action takes place. It results in uniform ramming throughout the volume of the molding sand. Here, if there is any extension or projection on the pattern, then it may break because of this external force. So that's why it is used applicable for only uniform cross sections. It is applicable only for uniform cross sections. If there is any projection on the pattern, it will break in by applying force. Next topic is core making. So as we have discussed that now mold we prepared, pattern we prepared, so next is core. What is the core? Core is used to produce hollow sections of castings. To understand this, suppose for example I want to produce a cubical shape component, then I can use solid pattern and insert in the mold and prepare a cavity, empty cubical shape cavity, pour into the molten metal into that, you will get solid casting. Instead of that, I need cylinder where inside is also hollow space. For that, if pattern, if you want to prepare pattern, it's difficult, right? The pattern has to be, once you insert the pattern in the sand mold, if you are going filling, how to remove that? You can't, it's not like breaking the sand, that one. If you break that once, solid, suppose if you prepared a wooden pattern, cylindrical wooden pattern, and you kept in the mold and fill the molding sand, so molding sand will go inside the cylinder also. You can't remove without breaking the mold. So if you break the mold, you can't prepare casting. So to avoid that, this core is used. What we need to do, we need to insert this core inside the cylindrical surface of the cylinder, which helps us to produce hollow casting. Core is also made with sand only. So CO2 molding is used to prepare core. So what is CO2 molding? CO2 react with sodium silicate, forms silica jet. CO2 plus sodium silicate forms silica gel. So the chemical reaction is huge, and I just wrote what are the components you will have to input and what you will get. It produces mold of high strength. Then remove the mold sand, it acts as a core. Strength of the CO2 molding is due to chemical reaction between the CO2 and sodium silicate, and it does not last for a longer time. Strength of CO2 lasts for few hours only. As the time goes on, its strength goes on reducing. Once strength goes on reducing means it's easily collapsible. The strength attractive force between the sand molecules is less, so it can easily breakable. We need, once we prepare the core, the moment you prepare the core, you need to use it for in casting. So properties of core material is it needs high strength, to withstand the buoyancy force of the molten metal. High collapsibility, it has to be easily breakable. Free from moisture. So these are the things we need to consider in core making. Positioning and location of cores, next topic. Core pins are used to position and locate the support cores. To positioning and locating the cores. core print is used to support the core. The core print is the part of the mold. So this is a sand mold, and we need to prepare a cylinder. This is sand mold, and this one is core to get the hollow cylindrical surface. Core. This one is casting cavity. Casting cavity, empty space where the molten metal is poured. So once if you pour the molten metal, core is used for, as we discussed, that the purpose of core is to prepare hollow sections, and especially for cylindrical internal cylinders, a cylindrical shape. To get the cylindrical shape, internal section, hollow section, we use core. So the core print is this area. So this part is core print. The supporting part, core print. There only we use pins and all those things, but this area is called core print, both sides. It's a sand only supporting the core. So core is manufactured by using CO2 molding, only special molding technique which we have to remember for 1 mark question. Here there is one concept called buoyancy. Buoyancy is because the amount of what is the size of the core print, or the extension of the core from the cavity into the mold, such that it can support, it can withstand the buoyancy force. Buoyancy means uplifting force. Suppose I inserted core into the molding cavity or casting cavity, and after pouring the molten metal, while filling the molten metal into the casting cavity, it tries to, because the density of the molten metal is higher than the density of the sand, it tries to apply, the external force acts on the core. So to withstand that force, it has to be some area, supporting area. So that's why here buoyancy force comes into picture. So density is rho is density of liquid molten metal. D is density of core material. So D has to be less than density. Due to this only the core is trying to float because of buoyancy force. The core, as like suppose if you throw some rubber or plastic into the water where water density is higher than the rubber, it will float. So similarly here, the density of the molten metal is higher than the density of the sand, so sand particles, the core tries to float in casting cavity due to buoyancy force. So buoyancy force is nothing but uplifting force. So resultant force on core, so because the core weight is acting downwards and uplifting buoyancy force is acting upwards. Suppose if you take this is a core, weight acts as downward, weight of core, and upward force is buoyancy force, BF, buoyancy force. So this is a core sand prepared with sand. Once you pour the molten metal into it, so resultant force on core equal to weight of the molten metal displaced, weight of the molten metal displaced minus weight of core. So resultant force RF equal to, weight means volume into density, volume into density, density equal to mass into volume, right? So weight equal to volume into density, density is rho into mass density into G equal to volume is same in both, D into G. So as we know that V and G are same for core, and rho is molten metal minus D is density of core. Suppose uniform cross sectional vertical, this is for horizontal core. For horizontal core, the resultant force is Vg into rho minus D. For vertical uniform cross section core, vertical uniform cross section, if this is uniform cross section, the resultant force is 0. Okay.